Hess's law is another way we can manipulate thermochemical equations. And Hess's law you can always recognize because you'll be given more than one reaction, and what you're going to do is add them as though they're algebraic equations. Just like we kind of multiplied through by a factor like it's a algebraic equation, we can add equations. So to add these two, anything that's a reactant here, those add. So I'll do this. And then all of these products. And then for the delta H, I will add those as well. And I'm going to mark that positive. So that makes sense. We just added the equations, but then we might notice that C is both a reactant and the product on this one, so it kind of cancels out. So we'll rewrite it without C. And in this case, C is what we would call an intermediate. It's a product that forms in the first one, but then immediately decomposes in the second one. Okay, and there is our net thermochemical equation that we got by adding these. The trick is that on a lot of these, you have to manipulate these equations, multiplying by factors and stuff, and then add them and to get your number here. So we'll look at a more complicated one. This is how the problems usually look. You'll be given some equations with their heats of reaction, and you'll be given what I would call like a goal reaction. What we want to do is to make it so that we can add equations and get this as the net reaction. The thing is, you can't necessarily do that like I did on that one on the slide just by adding these together. Usually you have to manipulate these first. And by manipulate, I mean multiply through by a factor or switch them, like reactants to products, switch those and these signs will change. So the tricky part, and this is kind of a little brain teaser thing, is to decide how to manipulate each equation. And the way to do that, and this is the most important part, you guys, look at your goal equation. I'm just going to start by looking at this one, at the carbon. And I say, okay, I need carbon, 2 moles of it as a reactant. And so I look up here and I look for every place I see carbon solid by itself, and I'm lucky because it's just right there. Okay, and notice it's a reactant on both of them, and it's also 2 moles on both of them. So that makes this one easy. I now know what to do with this first equation. I'm going to use it as is. I'm not going to manipulate it, multiply by factor or anything like that. Okay, next clue. Let me get this out of the way. Oh, maybe I should just mark that I'm going to use it as is. Okay, now I'm going to go to oxygen and see. So I look for oxygen all up here, and I see oxygen in 2 places. Well, that's unfortunate. That makes it more complicated to decide what to do with the second equation, because I'm trying to decide, do I need to reverse it or multiply by a factor? And frankly, that would just make me think too hard. So what I'm going to do is not use oxygen as a clue. I'm going to skip it and use the next thing. So the thing to watch for there, if you see something in your goal reaction that is in more than one place up here, then don't use it as your clue for what to do. Let's go to our last one and see if that works out. I need carbon monoxide as a product, and I need 2 moles of it. So I look all up here for carbon monoxide, and I see it right here. Okay, then I compare. Well, the problem is I have 2 moles, so that's good. I have the right amount. But the problem is here it says a reactant, and I need it to be as a product. So that means that I need to reverse the second equation before I add them. So I'm going to reverse it. And the way that I mark that on mine is that I put a negative sign. The reason I do that, a negative sign to me means flip this equation, and it means to multiply this by a negative number. So remember, when you flip an equation, reactants to product, you change the sign of the heat of reaction, the delta H. Okay. This one's, believe it or not, this one's pretty simple, but it's a good idea to rewrite these if you're going to check. By the way, right now, if I wanted my answer and if I were in a hurry, what I would do is I would just, like on a test or something, I would just change the sign and add those numbers, and I would get the answer. But let's show how it is you know and how you can check your work. Okay, so I'm going to rewrite the top one as is. Okay, and then I'm going to rewrite the first one, the second one, and flip it. In other words, I'm going to make the product the reactant and so forth. So I'm going to put 2. And when I flip this, I'm going to change the sign. I'm running out of room here, plus. So I changed the sign of the negative there. So I flipped that reaction. And then I'm going to add these 2 equations. So I don't have room, so I'll do my products down here. And so what I'm doing, just adding these 2 numbers, I get a negative 221. Okay, and so that is the answer that we're looking for, is that I just added these 2 after I did the flipping. But let's go ahead and see. This is a way to check your work to see if it really was correct. So to do that, what we are going to do is we are going to kind of cancel things out here. So you look for things that can cancel that are both in the reactants and products. And right now I see carbon dioxide, 2 moles of it is in both the reactants and products. What else? Oxygen. Oxygen is a little trickier. I have 2 moles in the reactants and only 1 in the product. So it's going to cancel the 1 in the product, and I'll change this 2 to a 1. And anything else that can cancel? So I got rid of the CO2, the oxygen. Okay, and so after canceling those out, I can see what's left. So just rewriting. And look at that. We have this goal reaction that's left. So that's how it works.